Hi, my name is Akash Kapoor, and I'll be walking you through the SAS training, giving you what SAS is, what is data analytics, and how the job scenario is in SAS. And then we'll move on to a case study to understand how SAS works in a real life. A little bit about my background. I have more than 2 decades of experience, and my first interaction with SAS was in US during my master's, and that was in 2004. That was the first time when I was doing my thesis. I learned SAS, and I felt that it is something which I'm interested in. And along the way, I had been doing different projects with SAS, and also I'm a base SAS certified professional now. My journey since 2006 had been into different analytics tools, SAS being one of them, and there are others as well. So I'll just focus on SAS rather than going into other tools. So we'll get on with our training for SAS now. And what to expect in today's training is data analytics. What is data analytics? Data analytics tools. Why SAS? What is SAS? SAS features, coding in SAS, use case. Use case is the case study. And then the SAS job trends. So you might have heard of that a data scientist, it's the sexiest job in the 21st century. So what is data analytics? Now if you go to Walmarts or say big bazaars here or any other departmental stores, whenever you check out, you see small things like the chewing gums or lip balm. Now how are these things placed here? Why not bottle of oil? Why not say something bigger than that, a detergent? Now there is a logic behind it. What they do is they study the trends, they study how people buy, what things to be kept near it, which will increase the sales. So there is a study behind it, which is called data science or analytics. That's how the things are placed where they are. It's called market basket analysis. People who are buying this should be buying this, where you should be putting something in the store to get more sales. Now, data is everywhere, and it's just that we have to recognize the pattern. We have to recognize how it works to increase our sales. So data analytics paves the way for the creation of next-gen products. Now, as I was mentioning that where to place it, based on this placement, you come up with a model, and the model can be developed into a product, and you can have that sold out in the market, that this product actually optimizes or maximizes your sales. Data analytics help manage resources so as to reduce costs, faster and better decision making. Analytics enables better work-related decisions, meeting customer needs through better services. So primarily, it's in a nutshell, it's actually helping the customers, helping the business. Customers are finding their stuff easily. The business is getting more margins. So as I mentioned in this small example, so this is all entailed in data analytics or data science. So data analytics, you get the data, you will get some historical data, you will actually prepare it, manipulate it, develop a model on it, and take some decisions based on it. Data analytics examines large and different types of data to uncover hidden patterns, correlations, and insights. Correlation is people who are buying some product A will buy a product B. There is some correlation between the two. Hidden patterns are in the beginning of the month, people buy this kind of product. So those are the patterns you can discover from the data. There are different data analytics tools. You have the paid tools and you have the open source tools. So you have the distinction here, paid tools, SAS, Tableau, Excel, ClickView, Splunk. Open source are R, Python, Apache Spark, which is gaining momentum now, Apache Storm, Pig, and Hive. The difference between paid tools and open source is paid tool, you can get support from the vendors, whereas open source, you may not get any support. Paid tools, whenever there is a new patch, it will be installed and you'll get to know that this is a new thing coming in, new features coming in. Whereas with open source, it's random and anyone can actually publish and kind of have its library in R, same could be in Python and so on. Now, the question comes, why SAS? There are so many tools in the market. SAS in the Gartner's Magical Quadrant, it's in the leadership quadrant at this point. It has the maximum market share, and besides that, it's ease of learning. data handling capabilities, graphical capabilities, advancement in tools, and job scenario. What is ease of learning? SAS is easy to learn and provides easy options for people who already know SQL. R, on the other hand, has a very steep learning curve as it is a low-level programming language. And as it's written that R has a steep learning curve, whereas SAS, on the other hand, be it SQL, be it SAS programming, it's much easier to write those codes. Or if you write a proc SQL, SAS understands that it's a SQL statement which is coming up, and you can write, after opening up proc SQL, you can write all the SQL statements and that with a quit. Data handling, SAS is on par with all leading tools including R and Python when it comes to handling huge amount of data and options for parallel computation. Now there is a SAS grid also in the market now, which actually splits the partitions and kind of handles huge data. And any analytics tool, if it cannot handle huge data, because more is the data, better is your prediction. So data handling is another capability which SAS is good at. Graphical capabilities, SAS provides functional graphical capabilities with a little bit of learning. It is possible to customize on these plots. So once you actually get into SAS, you can see graphical plotting it's like a cakewalk. SAS releases updates in controlled environment, hence they are well tested. R and Python on the other hand have open contribution, and there are chances of errors in latest developments. So as I mentioned, SAS is a licensed software. So whenever there is a new release, as it's mentioned here, so SAS releases updates in a controlled environment, hence they are well tested. And you would know that there is a new patch with so many such and such features. You'll get a support as well for R and Python that would not be there. Globally, SAS is the market leader in available corporate jobs. So besides jobs, SAS also has a maximum capture of the maximum market share of the data analytics. So I think in 2015, the data was like 35% market share. As far as job trends are concerned, SAS controls about 70% of data analytics market share compared to 15% for R. So that's the Indian statistics. What is SAS? Statistical Analytics System is a software suite for advanced analytics, multivariate analysis, business intelligence, data management, and predictive analytics. So SAS is used not just for analysis purposes, even you have the quality assurance, project management, data integration, all those things are also in SAS, and they have different tools for that. In fact, there are customized SAS tools or SAS softwares for like clinical domain, and for integration or the ETL piece, you have a SAS data integrator. So they have come up with several tools. It is developed by SAS Institute. SAS provides a graphical point-and-click user interface for non-technical users and more advanced options through SAS language. SAS features, it's flexible, extensible, integrated, powerful. It provides business solutions. So I'll be repeating what I have been saying. So business solutions, of course, you can develop the models on it. Analytics, of course, decision-making on a predictive model, data access and management. So it can access data from different databases, also from the files. Reporting and graphics, of course, you can have SAS BI, or it's the SAS reporting tool, and with good graphics, as well as even in the base SAS, there is like a proc summary, a proc report, which can actually pull up the reports for you. Visualization and discovery. Visualization, once you visualize or you plot a graph, you can easily see if there are any outliers or how much is the variation between the model and the actual data points. So visualization and discovery is another piece what you can handle here. Let us look at some of the features of SAS in detail. Reporting, as I mentioned, it can access data from different sources, be it flat files, Oracle, or other databases. It can pull the data and report out of it, or it can send the reports to recipients directly. Without, you can schedule the program and it can run and send the reports. Data, access of data from different sources, be it a text file, like CSV, Excel, or different kind of databases. So there's a good number of data it can connect to pull up the reports. Transformations, SAS Data Integrator actually helps you with the transformations. It's an ETL tool, like you have Oracle Data Integrator, Informatica, and so on. There are 4 capabilities in SAS. access, manage, analyze, present. Now, in any of the data science project, if you see, these are the four pillars. Access is like a data collection. Manage is like a data preparation or manipulation. Now, this is, again, I would say, the four phases of the data science project. Then you have analyze. So you're building a model, and then you're presenting the inference from the data. Access is the data collection, and as I mentioned in the previous slides, it can connect to several databases or the raw files, flat files, and once you actually access the data. Now, one thing to be noted is SAS does not directly work on your database. It creates a data set in SAS. You will actually import the data into SAS once in a SAS library in a SAS format, which is a SAS 7 BDAT. Once you have that, only then SAS will work on it. So once it is in, only then you can actually analyze it, manage it. SAS provides excellent data management capabilities, subset data, create variables, validate, and clean data. So in any of the data science project, the maximum time goes into the data preparation, or as it is mentioned, manage. So you can create the subsets, new variables are created. If you want to drop some variables, those can be done. You can validate and clean the data. So entire manipulation piece is done in the manage. We can perform simple analysis like frequency and averages, complex analysis including regression and forecasting. SAS is the gold standard for statistical analysis. So variables in SAS is like the columns, as we call it. They're called variables in SAS. And each row in SAS is called an observation. So observations are and variables are how we actually move into SAS. And whenever you bring the data into SAS, you have the variables on which you'll be working on, or the columns as we call it in the table. They're called variables here. So you can manipulate some variables, or addition of variables, creation of variables, or maybe part of the data you want, and then you can work on it. So SAS for analysis, now you can do a descriptive as well as predictive analytics. Descriptive could be the mean, median, modes, and the predictive analytics would be regression forecasting. It can actually do all this stuff. In fact, whenever you get the data, the first thing one should be doing is to check the metadata by proc contents. So proc contents actually lets us know what are the variables, how many observations are there. All those things are actually defined in this result of the proc contents. Once you have proc contents, proc print is another one which you should be doing to see what the data is. And then based on that, if you want some manipulations, you can do that and then kind of work from there depending upon what the project is, whether you want to see the frequency of something or the mean, or maybe actually doing some regression and forecasting. We can present our analysis in the form of list reports, summary reports, graphic reports. Now it depends upon what the ask is. Eventually there will be a report what you're going to pull out, which you have to show to your, say, a C-level executive or maybe your client. So eventually there will be a report which actually, when you collected the data, you managed it, analyzed it, now some inference has come out which you want to present. So you have different ways of presenting it. It could be a list report, like a tabular report, summary report. Summary report is like an aggregated report. Graphical report, maybe some visualization is required. So those things are all present in SAS. Coding in SAS just has two steps. One is a proc step and the other one is a data step. That's about it. So SAS is pretty simple that way. Proc step and data step. So from a proc statement starts with a proc, and then you have contains, proc print, proc means, ends with a run. Data step also starts with a data statement, ends with a run. Proc SQL starts with a proc SQL, ends with a quit statement. For SAS to understand that it's a SQL statement coming, you'll open a proc SQL, write the SQL statements, quit at the end. Data step is data, some data set name, and whatever the SAS statements you want to write, and then it's going to be a run. Same for proc contents. You write a data set name, and at the end you have a run. So data step typically creates a SAS data set. However, you can use data steps to create raw data, program files, and the reports. The data step is very flexible. A proc step typically creates a report. Here is a small code, SAS code. A SAS program is comprised of sequence of steps, and a step is comprised of sequence of statements. Every step has beginning and ending boundary. These are called step boundaries. SAS compiles and executes each step independently based on the step boundaries. Here is a data step. As I was mentioning, data, and then you have that library dot the dataset name, where country is equal to AU, and run. Run is where you are ending it. Title, if you want to give the title to this, actually the preceding ones will get the title new sales employees. You're printing the data with a proc print. Data is equal to your library name dot the dataset name. After that, it's a run statement, which is letting it know that the proc step ends here. Proc means data is equal to library dot dataset name, and then you have grouping it by job title, and what variable you're actually calculating the mean on or the average on is a variable salary. With a run, you are actually letting it know that it is ending here. A data step begins with a data statement, and a proc step begins with a proc statement. SAS detects the end of the step when it encounters one of the following: a run statement for most of the steps, quit statement for some procedures, the beginning of another step. So as I mentioned, beginning and ending, it's actually written here in this slide. The beginning with the data step and ending with the run, same for the proc. We'll submit the code and check the log. The results are as follows. The first report is the proc print report. Here is the proc print report. Proc print data is equal to work.new sales. We'll submit the code and check the log. The results are as follows. The first report is the proc print report. We already gave it a title. The title is new sales employee. The next report is the proc needs report. Here SAS calculated the statistics for the analysis variable salary. The means procedure provides data summarization tools to compute descriptive statistics on your data and displays output by default. Now, by default, it will give you the number of observations, mean, standard deviation, maximum, and minimum. There are several other descriptive statistics which proc means can give, but by default, it's going to give the ones which you are actually looking at. The next report is proc needs report. Here, SAS calculated statistics for the analysis variable salary. The means procedure provides data summarization tools to compute descriptive statistics on your data and displays output by default. So by default, these are the descriptive statistics which proc means calculates. Depending on your result, you might need to repeat some steps. The power of SAS is that you can use it to read any type of data, including the following three major files. The raw data files contain that has not been processed by any other computer program. So it's primarily the text files, what raw data files are, and it can pull that records. There are different ways of getting it and letting SAS know that it's in the columns. You can define where each column is starting, or you can let it know that these are the variables which are coming in. So different ways of actually getting the raw data file in. SAS datasets are specific to SAS. A SAS dataset is data in the form that SAS can understand, like raw data files. SAS datasets contain data, but in SAS datasets, the data is created only by SAS and can be read only by SAS. So as I mentioned earlier, SAS will not be actually working on the data in a database or external file. It will actually, you'll have to import the data into SAS library. That will create it as a SAS dataset, and on that you can actually manage, analyze whatever you want to do. So it is converted into SAS format, only then SAS works on it. SAS program files contain SAS programming code. These instructions tell SAS how to process your data and what output to create. You can save and reuse SAS program files. So of course, you can make the data set as a permanent data set or a temporary data set. So temporary data set resides only as long as your session is open, the instance is open. Once you close that instance, the temporary data sets are gone. You can make them a permanent data set by actually saving it in a permanent library. That way, whenever you actually open the SAS, you'll have those files there, data sets there, and we can work on it. Let's look at a case study to actually understand how SAS works, and this will help us walk through our SAS coding as well, and will relate it to the real world. So bank data analysis using SAS introduction. So now what is this case study about? KM Bank is a commercial bank in Delhi. It has two branches, north and southeast. The bank has a call center in each of these two branch regions to cater to the needs of the customer. Data is stored in different Excel files, due to which it sometimes gets complicated and time-consuming to retrieve information about a customer. So there are two call centers where there are incoming, outgoing calls for the banks, and the data is in silos. So North branch actually deals with their own data, South and East branch deals with its own data. So data is stored in different Excel files, due to which it sometimes gets complicated and time-consuming to retrieve information about a customer. Therefore, they're looking for a way to blend the data such that they have the information they need in one data set, and also with that they are able to draw some insights through the data. What is the problem statement? Extract meaningful business side insights from the bank customer by merging both the branches' data using SAS functions. Use these insights to find high-value customers, value correlations, and effect of sales calls on various products the bank has to offer. So we'll have a detail. What we have to do is analysis to be done is combine the data from both the bank branches for further analysis, find out the total number of calls made to every customer from outside his or her branch. So if a person is residing in the area of North branch calling to Southeast, or Southeast customer calling to North, so find out the total number of calls made to every customer from outside his or her branch. Give a bivariate frequency of customers by gender and age group. There's a cross-tabulation between gender and age group. Find a relation between customers' age and the bank balance. Is it like the people or the customers who are more in age have a better bank balance, or vice versa? So these are the things which we need to figure out. Let's have a look at this case study here. I'm just going to call the library where I have imported the files, and we will work on these files. Now, the files what we have are the demographic files or the data set. Demographic is like the gender or the name, date of birth. It has the account number or the customer ID. And then there are three more data sets. One is about the open accounts, the accounts which are active right now. Third one is the North call center data set, which is about the calls, when the call was made, what was the duration of the calls. Similarly, for Southeast, we have a data set for Southeast, which has the same data variables as there are in the North one. But the only difference is it is just for the South, and the other one is for the North. So let's just have a solution to a few of the problems. And what we are going to figure out is bivariate analysis, as we are frequency and the correlations. And besides that, we will be actually looking at some more. I'll just explain to you what we are doing in each of these codes. Here we are creating another data set called demo1. We are formatting gender to character type with a length of 10. We are pulling the data from a demo data set residing in output library in format. That is how the data is coming in. Same for the date of birth. Now, if gender, I'm just pulling, if it's just F, let me just show you the file first, and then it's going to be easier to understand why are we doing this. Here is the data set, the demo data set, which has the customer ID, F name, first name, last name, city, date of birth, and gender. See the things here. Gender, you have M, M, F, M, A, M, A, L, E. So we want it to be consistent, maybe complete male or female. Date of birth, we have some missing date of birth as well. City, same here. So what we are going to do is we are going to have this concatenated as a name. The date function, or say the date in SAS, is taken as 1st January 1960 as it's actually a number in SAS. 1st January 1960 is taken as a date 0. From there on, any date going to the right of it is actually all positives. Anything before this is all negative. For example, 31st December 1959, SAS will read it as -1. 2nd January 1960, SAS will read this as 1. So that's how the dates are here. Okay, now going forward, what I'm going to do is I'm just going to pull, let's say, there is a blank here and there is a dot here. These are both missing values. If the data type of any variable, for example, city variable, the data type is character, it will be shown as blank. Whereas here the data type is numeric. Any numeric missing value would be shown as a dot. So that's the difference. And this is actually a base SAS exam question as well, where you'll then be asking, giving you something like this and ask you what is the data type of this particular variable, and it's going to be a numeric because it's a dot here. Now for this, actually we are going to have the gender one, gender consistent. How are we going to make it consistent? We'll just have a look at it because we have some MA, male, MF, it's not consistent. So what we are going to do is, in this code, we are going to use a character function called substring, in which in this variable, starting from the first alphabet, going only till the first position. So just pull the first alphabet from this. If it is F, then the gender is female, else the gender is male. So we are, from this particular data, we're just pulling the first alphabet. If it's M, give it a male. If it's F, give it a female. Regardless whether it's complete MALE or MA, we are just checking for the first letter. Full name, we are actually concatenating it in the uppercase using a compress function. If there is a trailing or preceding blanks, those have to be taken off, and then you concatenate it. City, we are actually putting it in the uppercase. Age, what we are doing is today, what is the date today, minus the date of birth. It will be a number. It may be a 2000 or 20,000. Divided by 365 converts it into the age. And here we are rounding the age to 0.01. So if I run this code, and now I print it to see what I've done on the code, here is what I get. See, we converted M, MA, F, M into a complete male, female, right? So there is consistency here. Customer ID, we did not touch it. City, we wanted it to be made as capitals. It's capitals now. We wanted the full name to be concatenated. This is concatenated. Age, we wanted it to be calculated in years. So what we did was today minus the date of birth divided by 365 because it calculates days. And by dividing by 365, we are calculating the years, and then we are rounding it off to 2 decimals, right? Okay, let's move further. Now there is data for the North call center. We are right now actually kind of making the data in a format where we want it, and then we can actually merge it or append it depending upon what the data is and what the requirement is, and then we'll finally come to the analysis. Let's have a look at the data from North call center. You have the call ID, you have the account number, call type, whether it's call coming in or it's going out, call duration, agent name, who called on, this is the date. This is in a SAS format date. Now, what we are going to do is, we see the account number is, it needs more space to get rid of this E. So we are actually assigning it 32 space. Called on, we are putting it in a format. We'll just have a look at that. Account number, we are actually changing it to character. There is a put function which actually converts numeric to character. From the substring, what we are trying to see is whether the call was from outsider or insider. Now the thing is, to identify whether the call was an outsider call or not, you have an in and out is fine, but whether it's coming from north to southeast or southeast to north, there is identification. So with the account number, if a substring account number going from first till 3 positions not equal to 1 to 4, not equal to, meaning the north center can be recognized with account number. If the account number is starting with a 1 to 4, it is from north. If it is not equal to 1 to 4, then the outsider, else outsider is equal to 0. Duration, data in this is in seconds. We are actually converting it into minutes. Okay, I have to print this. See, if its account number is 1 to 4, it's not an outsider. But if the account number is say 171 starting with 117171, this is outsider call, outsider to our Node center. We have changed the duration. We have actually put this instead of SAS format, we have put it in a different format here. We wrote date 9 dot, so that's how date 9 dot is coming. So the way we have done it for North Center, similarly we have to do it for the South Center, because the data in both of them, it's just the variables are all the same. The variables are all the same, but the data is different because it's for North and the other one is for South. So what I'm going to do is I'm going to repeat the same exercise for South. Now, since the data in both of them is the same, what we want to do next is we want to actually combine this data. So there are two types of combines. One is an append, the other one is a merge. What is an append? Append is a vertical concatenation of data, meaning one below the other, whereas merging is a horizontal concatenation of the data. So for example, in this particular one, in this data, let me show you with an example here. Then let's say variable A and B. Here you have some data, C001, C002, C004, and here you have 200, 300, 400, and here you have variable A, variable C. And the data here is, let's say, C005, C001, C002, and here you have some other data, car, bike, car. When you do a vertical concatenation, which is appending, you will have this data and you'll have a variable This is how the vertical concatenation works. One data above the other, regardless of whether there is a common variables here. So this is called vertical concatenation. Whereas merging, there are different kinds of merges. It's like same like join in a SQL. You want an inner join, outer join, left outer join, a right outer join. That's merging here. So in merging, what you'll have is variable A, B, C. You have the data for this one, and you have the data for this, and you have the data here. There you go. Now this is a horizontal concatenation. This is called merging. This is a merge and this is a append. Right? So going back to our case study now, in our case study, what we had was the call data. The call data, we have the similar variables. We are just going to append it and have one file. So we're going to append it and have just one file, and then we can merge that with other data to actually make some analysis. So we did north and south. Before actually appending it, there is another file which is called accounts file. I'm just going to work a little bit on the accounts file. What we are doing is the account number, we are bringing it in the same format as they are in the previous ones. So I'm just going to run this. Just to let you know that accounts file has only the open accounts, only the open or active accounts, I would say. The accounts which are active, which are not closed. So it could be the data in the call center files. It could be that the people called there and after that they close the accounts, and those accounts would not be here in the accounts file. So accounts file is the one which has the active accounts. This is the accounts file. You have the customer ID, you have the type, the balance, what is the direction of the balance, open date, and the account numbers. So these are the account numbers which are active, be it from north, be it from south or east. A dot, I've already told, it's a numeric data type. That's the reason it is dot. Balance direction, whether it's positive or negative, and the type, whether it's savings, CC, current account, or a FD. Now the thing what we need to see is in this accounts file, we have the account number, we have the customer ID. In the demographic file, we just have the customer ID. We do not have the account number. And in the call center files, we have the account number. We do not have the customer ID. So what that means is the call center file cannot be directly merged with the demographic because demographic has a customer ID as a unique key and call center files have account number as a unique key. But there is nothing common in both of them. Whereas in accounts file, you have both the keys here. So through our open accounts file, we can actually combine this data sets. We'll just have a look at this. Now, after we are done with manipulating the data in all the 4 data sets, what we are going to do is we are going to append the north and south region data. We're just appending the data sets. We just print it. You have all the data appended here, 124 and 117. I'm just going to sort it on the account number and the called on. Called on is the date when the person called on. Then we'll do some analysis, create new variables here to actually answer our question or the business questions. What are we doing here is we are actually creating a calls one data set by account number. We are sorting it by account number. If the last account number, then last call, INTCK, this is another function which we are using for calculating the number of days since the last call. This is an automatic variable which is created, but here we are actually capturing that automatic variable. Last dot account number, then last call, we want the days called on and today. Difference between today and the day it was called, the day the person called. We are actually calculating the difference. If call type is, if last dot call num, then last call is equal to this. I mean, we are just capturing, as I mentioned, the number of days since the last call. If call type in, then call type is equal to 1, else call type is equal to 0. Whether it's a in call or outgoing call, we are just giving it a type 1 or 0. So we have already appended 2 data sets, the 2 north and south. And now we have actually, I'll just print this. For some of the accounts which we have a common account calling in, it will be the last one, the last call. See, last dot account number is in the last call, what was the date? From today, you have to subtract that day and come up with a number. For example, here we have 2013. So 1483 is the number of days since the last call. This is negative 20429. The reason being, we have data for 2073 here. So whatever the data we have, it's in future. So that's the reason it is negative. And then you have here call type, whether it's in or out. If it is in, we wanted it to be 1, else it is going to be 0, right? Now what are we going to do is we are going to merge this, not append. We are going to merge this data with the accounts data. So eventually we are going to merge all the 4 data sets to actually come up to the bivariate analysis or correlations. So for merging, the primary condition is you have to sort the data by the variable on which you are going to merge it. So you sorted the calls data, now you're going to sort the accounts data. Here is the syntax for merging. Data call account, merge accounts and calls in A, in B. So what we are saying is, we are calling the data is coming from A, this is coming from B, and if A is like a left join. So whatever is the value in accounts, whatever the account number is present in accounts, those will show up. The reason for that is accounts has the active accounts. We want the active accounts. Keep cust ID and account number. This is another option what we are using. The keep option, we are actually keeping the customer ID and the account number from the data set accounts. From calls, we are taking everything. So we're just going to merge this data. Here, there are active accounts which have not called to the data center for the time in which actually this data was captured, and that is fine, not an issue. We have the customer ID, account numbers, called on, call ID, whether it was in, out, duration, who was the agent name, whether it was outsider, the last call, and the call type, in or out, right? So we've already combined 3 data sets. We appended the call data from north and southeast, and then we actually merged the accounts data with it. Now the next one is we are actually using descriptive analytics. We are actually using proc means on the call account. What we are calculating here is class customer ID. We are grouping it by the customer, storing the data in call stat, number of calls, incoming calls, mean duration of the calls, average total number calls, sum of the call types, sum of the outsider calls, maximum last call. So once we have this, I'm just going to run this. Here we've got by default type and frequency, which we might not require. Frequency is a number of observations for this particular customer ID is 2, 3, 4, and so on. Total calls made, total calls 1, 2, 4, whatever. Average total number of calls, just a second. We had the mean duration, sorry, the average duration of calls. Number of calls, which is the sum of the call type, sum of the outsider calls, which this is inside, or the outsider call is from one call center to the other, and the last call is maximum last call is when the last call was made to the call center. Let's calculate some more statistics here. We are sorting this by customer ID and open date. And what we are going to do is we are going to calculate the month on books. Month on books is since when the person is with the bank. So we are creating another data set, or say the same data set we are modifying, calling it accounts. If first.cust ID, then month on books is equal to intck, which is month. We are looking for months. intck function is just going to calculate the interval or calculate the duration. Earlier we calculated it on days. Here we are calculating it on months. Month, open date, today. So you're going to subtract from today the open date. Open date is when the account was opened. If the balance direction is equal to negative, then we are actually multiplying the balance by -1. If the type is FD, then the balance 1 is equal to 0. So we are looking for savings and current account only, not the fixed deposits. Let us print this. Okay. Customer ID type, we already changed it. If it's negative, we are multiplying this by negative. We can drop this actually going forward because we've already kind of concatenated that, whether the direction is positive or negative. Open date, account number, month on books. So month on books is today minus this date. It's going to give us month on books. Balance 1, what we created is by multiplying the sign here with the balance. And this is what we get here. So we can drop some of the variables. For example, we have this balance and balance 1 pretty much the same. So we can, but what we have done is if the type is FD, we are putting it as 0 because we are looking for savings and current accounts. So we don't want that. And that's the reason we put 0 here. Otherwise, the balance is there, but it's in fixed deposits. Okay, so we are actually running this statistics, number of accounts for any customer ID, how many accounts are there, sum balance, the total balance, maximum month on books is all we are going to calculate here because a customer ID may have different accounts and we want what is the maximum month on books for that particular person. He may have a current account earlier, but then he opened a savings account, so we are just looking for that. For example, here, this is being captured with proc means the descriptive statistics. What we have for each customer ID, we have the number of observations, 1, 2, 3. The mean balance, standard deviations is there is just one record, so there won't be any standard deviation, minimum and maximum. Similarly, we have the balance, open date, month on books. 84 is the month on books here. And open date, 9th May. Balance is here. But means, proc means may not work good for open date. It may not give you good statistics. But for balance, it is going to give you good statistics. For month on books, if there are 2 or 3, it may give you good statistics. So that's what we calculate here, month on books, balance. And here are the number of observations. We had 3 here, 1 here, and so on. For balance, we had the 3 observations, open date. Again, there were 3 observations. The person could have opened a current account, savings account, and a FD. Month on books, they were open on the single date. And the balance, again, we had, as mentioned above, we had balance positive, negative, or we may have a current savings and FD. Here in balance 1, we are actually eliminating the FD and then calculating the mean. And here we are taking the entire one, the current savings and the FD, and that is the reason these two are different. Right, so just to have this data, the previous data look little better, we are actually dropping the type and FREC, which come by default. Number of accounts, the total balance, and month on books. This is what we get for our account stats, which we created right here. Okay, right here. This was created here. And this data looks much better than what it was earlier. So number of accounts for each of them, total balance, and the month on books. Total balance actually excludes the FDs. Okay, now we are merging the account stats, which is the statistics data, what we had, the call stat, which we earlier calculated, and the demographic. Before actually merging it, we have to first sort it, and we are sorting it by customer ID because now all the 3 data sets have customer ID. So after sorting it, we are merging the demo, the count stats, and the call stat by customer ID. We are dropping some of the variables, which are actually 2 of them are coming by default. Date of birth we don't want because we've already calculated the age, so we don't want that. Here we see the gender, customer ID, city, full name, age, number of accounts, total balance, month on books, total calls, average duration of calls, number of incoming calls, outsider calls, and the last call. So the entire data set, if I now relate it to the previous one, our slides when we started, we said access and then manage. Access was importing these 4 data files. Manage is what we are doing or preparing the data for our analysis, which is the next step, and then the presentation. So all the 4 pieces, all the 4 framework phases of a data science project, which was actually mentioned in the SAS framework as access, manage, analyze, and present. So access, and this is the manage piece, which takes the maximum time. So once we have this data in place with all the variables, what we can next do is go for a bivariate. Bivariate frequency, if I go back to our slide here, give the bivariate frequency of customers by gender and age group. Now with proc-frec, it's always good if you have data categorized. If it is categorized, it's easy to interpret the cross-tabulation. Whereas, for example, if it's just numeric, a person is in this population has age 21, 22, 23, 24, 25, and so on, and you have some other data where you are actually doing a cross-tabulation by gender, so it may not give for 21, you have 1 female, for 22, you have 1 male. That may not give you much of information, but if you categorize it, up to 24, very young, 25 to 35 young, 36 to 50 middle, and so on, then it'll make sense. I'll just show you what I'm saying. But on this data, we just have the age. We do not have this categorization. And for that, we are going to use a proc format. With a proc format, we are actually creating a format called age. And how are we defining it? Low to 24, we are calling it young. 24.1 to 35 is young, and so on. I'll just run this format. Now in the format, you have defined this format and you have to apply this format on some data set. In this case, what we are doing is we are doing a proc-frec on this particular data set what we created. We are doing age to gender cross-tabulation. On the age variable, we are actually applying the age format. And let's have a look at it. See here. This is a cross-tabulation of age versus gender, or the contingency table. Here what we have is the top row is the frequency, and underneath it is a percentage. So in this population, we have 35.71% of females which are young. We have 35.71% of males which are middle-aged. 7.14% of males are old. And on the sides, what we have is, this is a total percentage of young people in this population. This is a total percentage of middle-aged and the old. Total female percentage is 35.71 and male percentage is 64.29. We have one missing, which will not be calculated here. So that's how we interpret this. And the reason why I'm saying was characterizing it or say categorizing it was, now we have young, middle, old. Instead, if we had left the data the way it was, it would be 21, 22, 23, 24 and so on, different ages. For 21, you have one female, 22, you have one male, but that's not going to give us any good output or any good inference. But here we can have a good inference. Now the next question, if we move on to, is there a relationship between age of the customer and the total balance? Is there a relationship? If I go here and calculate a proc core is a correlation between the two, age of the customer and the total balance. So we are doing a variable age with total balance, and it will provide us the statistics. First of all, it is letting us know with variables, total balance, variable age. Next, it is telling us this, giving us the simple statistics. So by default, it is going to give us the simple statistics. We had 15 for age, maybe the date of birth was missing for one of them. So we had 14. Whenever this is calculated and there is a missing value, the missing value is not taken into account. So this average, what has been calculated, is based on the 14 observations, whereas this is calculated on number of observations here, which is 15. So this is the simple statistics which comes with proc means as well. By default, this comes with proc core. What we are interested in is this piece. At the top is a correlation. They are negatively correlated. They are negatively correlated, and this is the p-value. So p-value in most of the industries, if it is less than 0.05, we say that the relationship is significant. And this is called the rho, Carl Pearson's correlation coefficient. We are seeing it negative, and we see this relation as significant. What this means is, as the age increases, the total balance is decreasing. That's what it tells us. Next, what we do is there a relationship between the age of the customer and the city? Is there a relationship? Now, we are tempted to use a proc core again to find the correlation. Proc core only works on numeric data. So what it is asking for is go with the categorization what we created. We have to do with that. Whereas proc core will not work on the character data. It just works on the numeric data. So what we do is we use a chi-square test. Chi-square test is actually a test of association, whether the two variables are associated or not. So there is a null hypothesis that they are not associated or independent, and the alternate hypothesis in this is they are associated. So what we are trying to figure out is if they are associated or not. This will give us several other statistics, but we will be concerned with the chi-square test only, and we'll just see how it comes. And what we are doing here is we are doing a cross tabulation of city and age, and on the age we are actually applying the age format which we described here, right? So the first thing what we get is the cross tabulation between age and city. Here is the proc cross tabulation on the contingency table, and here is what we get, what we are interested in, the chi-square. We get the value of chi-square is 19.31. The p-value is 0.01, which tells us that this is significant, and we will reject the null hypotheses and say they are associated, because our alternate hypothesis is that they are associated, and null hypothesis was that they are not associated. How is the degrees of freedom coming in? Degrees of freedom is row minus 1 multiplied by column minus 1. So the row minus 1 is, you have got 1, 2, 3, 4, 5 rows. 5 minus 1 is 4, and you have 1, 2, 3 columns. 3 minus 1 is 2. So 4 into 2 is 8. That's what the degrees of freedom is. Meaning, if you are calculating degrees of freedom for this, you still have 4 rows left and 2 columns here. That's the degrees of freedom for each of the cell. So as I mentioned earlier, that it's actually a test for association. The chi-square is a test for association. What we were trying to find out is whether they are related or not. So in this case, with our p-value significant, we will say that they are associated. City and the age are associated. So there is a relationship, right? Okay. Now let's see with our case study, we have come to the end of it, and let's go back to our slides. The job trends. So here what we see is on the job portals, this is a February 15, 2017, what the data has been pulled out. Or say the job postings, what we are seeing is, no, sorry, the data is not pulled up for February 17. It's just the mark what we are seeing was for February 15, 2017. On February 15, 2017, there were the SAS. The following is a job trend for SAS and SAS modeling across the world. SAS has been market leader when it comes to data analytics jobs. So 47.2% in data analytics, we were seeing SAS and SAS modeling as 11.3%. Now this trend actually kind of peaked in 2015, which was like around 58% in SAS. Same in the SAS modeling. Also, you could see the terms where SAS modeling was used in the job description. That also spiked in 2015 to like 24% or so. So at this point on February 15th, when it was pulled out, we can see 47.2% of data analytics jobs showed SAS, and SAS modeling was another 11.3%. So quite a substantial data analytics job has SAS in demand. So that's what this graph tells us. Now let's summarize before we conclude. We learned about data analytics. As I mentioned, data is everywhere. We have to find the patterns. We have to find some predictions for the future. And based on that, we can actually plan our inventory and kind of increase our sales or the margins. Data analytics tools. There are paid as well as open source tools. SAS is the leader. It's in the leaders quadrant in the paid tools. It's in the leaders quadrant of Gartner. And there are several other tools, Tableau, Excel, ClickView, and Splunk. Open source tools, in contrast, do not give you any support. And the new patches, it's not tested. It's just people develop it and they just put libraries in R, and same with other tools. So SAS is an easy to learn tool, and the data handling capabilities are pretty good, graphical capabilities. Advancement in tools is like they are coming up with different tools meant for each of the verticals. For example, as I mentioned, the clinical data. For clinical analysis, they have like clinical SAS, and same for other verticals as well. So SAS actually is used for analysis. It can be used for quality assurance. It can be used for project management. It can be used for reporting. It can be used for data integration. So different kind of tools for SAS, or the commands in SAS, which actually makes SAS useful in several areas. Features of SAS. So as I mentioned, the 4 pieces of the framework: the access, the management, the analysis, and the presentation. So it provides the business solutions by accessing the data, manipulating it, analyzing it, coming up with a model which gives us a prediction whether this is going to be good or bad for our business. And it is extensible, integrated, and powerful tool. We also learned about the coding in SAS. We went through the case study to actually see the business use of SAS. And in the end, we actually saw the SAS Job Trends, which was, we are seeing quite a good number of data analytics jobs, or I would say almost half of the data analytics jobs in the market across the world actually shows SAS. So it's a good tool to learn, and of course has a good potential, good job market as well. So I would say it's a good tool to learn. With that, I'll come to the end of this presentation. Well, thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!